Hello viewers, in today's class we are going to solve one important conceptual integral in which the integrand is a signum function, right? So here we have to find the value of the definite integral from minus pi to pi x signum of x dx, right? So let us start. So here we have the integrand as x times signum of x, right? Okay, so now before proceeding further, let us first take the definition of signum of x. Now we know that signum of x is defined as this value signum of x, it takes the value plus 1 when x is greater than 0, and signum of x is 0 whenever x is equal to 0, and signum of x is equal to minus 1 whenever x is less than 0, right? So this is the standard definition of signum of x, right? Now we have to evaluate this integral, right? So what we will do, we'll take the real number line, and here we have minus infinity, here we have plus infinity, and we see that the lower limit and the upper limit are minus pi and pi respectively, right? So minus pi, it lies somewhere here, and plus pi, it lies somewhere here, right? And this x is equal to 0, it lies somewhere here, right? And now if we closely examine the definition of signum of x, then we see that whenever x is greater than 0, it means whenever we go towards the right of x equal to 0, then signum of x takes the value plus 1, right? And whenever we move towards the left of x equal to 0, then here we have x is less than 0, and signum of x takes the value minus 1, and at this point signum of x, it takes the value 0, right? So this picture is clear, and now let us break this integral as a sum of two integrals, right? That is, I can be written as I1 plus I2, right? And x is equal to 0 is the point where we have to break the limit, right? So the first integral, it goes from minus pi to 0, from minus pi to 0, and here we have x times signum of x dx, right? And the second integral, it goes from x equal to 0 to x equal to pi, right? So this is how we break the given integral as a sum of two integrals, right? So now viewers, here we see that the limits are from minus pi to 0. So when x belongs to the interval minus pi to 0, then obviously all the values are less than 0. So this signum of x will take the value minus 1, and when x belongs to this interval, that is from 0 to pi, then all the values lying between 0 and pi are greater than 0, right? So signum of x will take the value positive 1, right? Okay, So now we can rewrite these two integrals as minus pi to 0, and here we have x times minus 1 dx, and here we have x times plus 1 dx, right? So now we can write it as minus integral from minus pi to 0, and here we have x dx, and here we have 0 to pi and x dx, right? Okay, so now we have two simple integrals, and these can be easily evaluated. So we have minus, and here the integral of x is x square over 2, so we have x square over 2, and the limits are from minus pi to 0, and here again we'll have x square over 2, and the limits are from 0 to pi, right? Okay, so now we can substitute the limits, and we'll take the difference. So when x is 0, we have 0 square over 2 minus pi square over 2, and here we have pi square over 2 minus 0 square over 2, right? So now this is minus, here we have 0 minus pi square is positive pi square, so we have minus pi square over 2, and here we have simply pi square over 2 minus 0, right? Okay, so now this term, it becomes plus pi square over 2, so minus and minus becomes plus, and here we have pi square over 2, so this is 2 pi square over 2, that is pi square, right? So viewers, the value of the integral minus pi to pi x times signum of x is equal to pi square, right? So here we have used the concept of signum function to evaluate this integral. So now viewers, we have seen that the value of this integral is pi square, right? Now let us see the geometrical interpretation of this integral, right? So here we have defined the signum function x in this way, right? And from the definition of signum function, we know that the graph of signum function, it looks like this, right? So this is plus 1, and this is minus 1, and this is the point 0, 0, right? So signum of x is equal to plus 1 whenever x is greater than 0, and signum of x is 0 whenever x is equal to 0, and signum of x is equal to minus 1 whenever x is less than 0. So here we see that all these points corresponds to x less than 0, and here all the points corresponds to x greater than 0, right? And this is the line y is equal to 1, and this is the line y is equal to minus 1, right? Okay, so this is the graph of signum of x. Now here the integrand is given as x times signum of x, right? So let us denote the function x times signum of x as phi of x, right? So now we see that phi of x is equal to plus x whenever x is greater than 0, because if we multiply both sides by x, then x times 1 is plus x, and x times 0 is 0 here when x is equal to 0, and x times minus 1 is minus x when x is less than 0, right? So the integrand x times signum of x is phi of x, and it is given by positive x whenever x is greater than 0, and phi of x is equal to 0 when x is equal to 0, and phi of x is equal to minus x when x is less than 0, right? So now let us plot this function in this coordinate system, right? So now viewers, here the limits of integration are from x equal to minus pi to x is equal to positive pi, right? So if we take x equal to minus pi in the negative x-axis, then it will lie somewhere here, right? This is minus 1, this is minus 2, this is minus 3, and this is minus 4. So pi is approximately 3.14, so it will lie somewhere here, right? Okay, so this is a rough graph of this function x times signum of x, right? So here we have this point is minus pi, and similarly x is equal to pi, so this is 1, this is 2, this is 3, and this is 4. So x equal to pi, it lies somewhere here, right? So this is the point plus pi, that is 3.14, right? Now let us take the first one, that is phi of x is equal to plus x whenever x is greater than 0, right? Now this function phi of x is equal to plus x is equivalent to y is equal to x, right? And this is a straight line with positive slope and passing through the origin, because this is equivalent to y is equal to mx, where m is equal to 1, right? So phi of x is equal to positive x. This is a line which goes like this, right? So this is the line phi of x is equal to plus x, right? And now let us consider phi of x is equal to minus x, where x is less than 0, right? So phi of x is equal to positive x, it will lie in the first quadrant because x is greater than 0. And phi of x is equal to minus x, it looks like the equation y is equal to minus x, that is y is equal to minus mx, where m is equal to minus 1. So the slope of this line is minus 1, and it will or it can be plotted like this, right? So this line would lie in the second quadrant, right? So phi of x is equal to minus x. So this line is phi of x is equal to minus x, and this line is phi of x is equal to positive x, and phi of x is equal to 0 whenever x is equal to 0, right? So this looks like y is equal to 0, right? And y is equal to 0 is the x-axis, right? So this is x-axis, right? So we have plotted the function which is our integrand. So now viewers, here we have x is equal to minus pi, right? And x is equal to minus pi is obviously less than 0, so we'll make use of this function. Phi of x is equal to minus x, so phi of minus pi is equal to minus of minus pi, that is plus pi, right? So here we have minus pi and phi of minus pi is pi, so this is the ordinate of this function at x equal to minus pi. So we'll have a line like this, right? So this is the line, and here we have the point pi, right? And this point is minus pi and pi, right? Okay, now when x is equal to pi, which is greater than 0, then phi of x is equal to plus x, right? And phi of pi is equal to plus pi, right? So this is the ordinate when x is equal to pi, right? So here we have plus pi, so we will have a line like this, right? And we have this point. So now this point is pi comma pi, right? And if we join or if we draw a line parallel to x-axis, then we see that the area, right, the area enclosed by this function is given by this shaded region, right? So the value of the given integral can be calculated, or it can be geometrically interpreted as the sum of these two areas, right? So here we have two triangles, right? So we have two triangles and the sum of the areas of these two triangles is the value of our integral, right? So we have this triangle, so the area can be denoted by a1, and the area of this triangle can be denoted by a2, right? So the value of the integral I can be given by the sum of these two areas, right? Now we know that the area of a triangle is given by half times base, the length of the base, and the altitude, right? So here we see that the base of this triangle is pi, right? That is this length, right? And the height is also pi, because from this point to this point the total length is pi, and moreover the coordinates of this point and this point are minus pi comma pi and pi comma pi respectively, right? So a1 is half base, so base is pi, and altitude is also pi, right? And a2 is given by half times pi, because the base is again pi from 0 to pi, and the altitude is again pi, that is the height, right? So we have pi square over 2 plus pi square over 2, right? This we have obtained earlier, right? So the area of this triangle is pi square over 2, and the area of this triangle is also pi square over 2. So this is pi square plus pi square over 2, that is 2 pi square over 2, and 2 get cancelled, and we are left with pi square, and which is same which we have obtained earlier, right? So viewers, here we see that this area, the area of this triangle A1, is given by the integral from minus pi to 0, from minus pi to 0, and here we have x times signum of x dx, and we have calculated that the value of this integral was pi square over 2, and a2 is given by the integral from 0 to pi, and the function is x times signum of x dx, and this we have also obtained as pi square over 2, and the sum of these two areas is pi square, right? So this is how we geometrically interpret this integral, right?